A common problem with analog two-way radios is that as the signal gets weaker, the voice coming through the radio gets quieter and harder to hear over the noise. This can cause a signal to be just too quiet and noisy to make out what the person on the other end is saying. However, there are some cool features to try and fix this issue by applying audio processing on both ends to improve the loudness and intelligibility of analog audio. The main part of this video is a sort of range test and demonstration comparing channels with these audio processing techniques, but I want to explain each of them first so you have the context to understand what's happening in the demo. The first of these techniques is pre-emphasis and de-emphasis. The transmitting radio boosts higher frequencies because these get more noise added to them than lower frequencies at low signal strengths. At the receiving radio, de-emphasis reverts this change, so the high frequencies are lowered in volume to bring the audio back down to how it naturally sounds. This also brings the volume of the noise back down at those frequencies, so you should end up with clearer sounding audio. The second technique is called companding. Again, this is made up of two parts, one on the transmitting end and one on the receiving end. The transmitting end uses a compressor, which basically brings the volume of quiet audio up by making it louder. The receiving end uses an expander, which brings that audio back down to where it originally was to try and reproduce the original audio. The effect of this is that when the signal goes over the radio channel and noise is added to the compressed signal, that noise gets quieter when it's expanded back out. Many radios have these features. I'll be using motor turbo radios in this video, but Hytera DMR radios also have the same features. My Kenwood PMR 446 radios have a compander option as well, and you'll find lots of other models, including analog only ones, also have these features. So I'm going to go out and do a range test at different locations to show you how these sound at different signal strengths and different conditions too. The main goal of this test is to compare the unprocessed FM with the emphasized and companded versions, but I've also put DMR into the comparison just because I thought it would be interesting, and since I was using DMR radios anyway, it was easy to do. Just in case you don't know, DMR is a digital mode, so the voice is actually digitized using a vocoder, which is a piece of software that tries to efficiently represent voice in a very small amount of data. It's then sent over the air as a digital signal, and then decoded back into audio at the receiving end. This gets rid of any noise on the voice signal, but if the signal quality is too bad, then it just won't decode, so you won't receive anything at all. Whereas on FM, you might receive a very noisy but still audible signal at the same location. Let's get started with the test.
Testing from the first location on a normal analog channel. Testing from the first location on a channel with pre and de-emphasis turned on. Testing on an analog channel with companding turned on. Testing on an analog channel with both turned on. And finally testing on a DMR channel. Testing on a normal analog channel. 1, 2, 3. Testing on a channel with pre-emphasis. 1, 2, 3. Testing on a channel with companding. 1, 2, 3. Testing on a channel with both. 1, 2, 3. And finally, testing on a digital channel. 1, 2, 3. Testing on a DMR channel. 1, 2, 3, 4, 5. Testing on an analog channel. 1, 2, 3, 4, 5. Testing on an analog channel with preemptive. 1, 2, 3, 4, 5. Testing on an analog channel with companding. 1, 2, 3, 4, 5. Testing on an analog channel with both. 1, 2, 3, 4, 5. And finally, testing on a digital channel. 1, 2, 3, 4, 5.
I thought that was really interesting. In my opinion, the audio with both emphasis and companding, so that is the one that came up with both on the display of the radio, was better, and I'd rather listen to that than the unprocessed audio because it sounded cleaner to me most of the time. Although the main goal wasn't to compare it to DMR, nevertheless, it was interesting to see how the digital signal was perfectly clear in all the locations except the one where it wouldn't work at all. The potential downsides of using emphasis and companding is that the signal you get out the other end is distorted and less like the original. But in my opinion, if it makes it easier to understand, then it's worth it. Another downside is that you need to have both ends set up the same way. You can't just enable these on your own radio and then go on an amateur repeater, for example, and expect it to clear up other people's audio if they don't have the same options turned on, since a lot of the work is done on the transmitting side. So would I recommend using these audio processing techniques? If you've got a system or group where you can get everyone to turn on emphasis and companding, then yes, I think so. What do you think? I'd be curious to hear from anyone who's used these techniques before and what your experience with them was. If you enjoyed this video, then I'd appreciate it if you could click the like button, and if you want to see more like this, then you can consider subscribing.